Thank you for coming. Today, I'm going to talk about how Toyota scaled cloud onboarding with HCP Terraform and AFT. I'll start with a brief introduction about myself. My name is Takayoshi Naito, but you can call me Taka. I work as a platform engineer in the CCOE at Toyota Motor Corporation. We are focused on developing our cloud platform and improving our internal developer experience. I'm also a HashiCorp ambassador this year. I'm really excited to have the opportunity to share our cloud journey here at HashiCorp today. I have a quick question here. Could you please raise a hand who here has faced challenges in keeping both governance and agility within your organization? Okay, thank you. I believe agility is a key benefit of the cloud. However, if we focus only on it, we might risk losing governance. I think it's important to balance governance and agility. Here's the agenda. First, I'll explain the challenge we've faced. Then, I'll provide an overview of the platform we developed to address this challenge, which is called Toro. After that, I'll dive into our cloud journey with HCP Terraform and AFT, including how we've utilized and improved them. First, a challenge in scaling cloud adoption. As you know, Toyota Motor Corporation is traditionally known as an automotive company. However, we are currently undergoing a formal change into a mobility company. This means we're expanding our focus beyond just automotive to the entire field related to mobility. For example, we aim to develop a mobility ecosystem that integrates with cities and society. To achieve this, we need more agility and flexibility than ever before. The cloud is an important technology to support this, and Toyota Motor Corporation has invested heavily in the cloud. During our cloud journey, we have expanded more and more from using it in a few projects. However, a few years ago, we faced twin bottlenecks. Whether we would fail to leverage the cloud, or we could overcome these bottlenecks and continue to grow our cloud adoption. It was a critical turning point for us. Here are the twin bottlenecks. First, manual process. Many tasks related to account provisioning and initial setup were done manually. Simply using Terraform alone was limited in its automation and could not cover the entire workflow. Second, security requirements. Many proprietary security guidelines already existed within Toyota Motor Corporation. It was the responsibility of the developers on each project to ensure their security settings complied with these security guidelines. As a result, the security levels varied between projects. Unfortunately, this variation sometimes led to security incidents. We need to be more secure, more agile, without compromise. In the process of promoting change into a mobility company, we were managing more customer data than ever before. We need to manage this data securely And we want to continue to create better products and producing happiness for all. We must always be a company that is trusted by our customers. Next, I'll provide an overview of our platforms, Toro and AFT. First, let me explain Toro. This is the high-level architecture of Toro. Toro consists of 5 main components. First, let's look at the top left section, Toro base. This is a core of Toro, responsible for account provisioning, initial setup, log management, and other essential features. In short, it's a landing zone component. On the right, you can see Toro CI/CD, observability, tools, and ISC. Today, I'm talking a lot about security, but we are also working to make the features that are generally needed for application development and operation more user-friendly. Internal developers will use AWS accounts, CI/CD, and other useful features provided by Toro. As you can see, Toro has a wide range of services, but today I'll focus on the configuration part of the Toro base, including account provisioning and security settings using AFT, and HCP Terraform, the core of Toro ISC. We have achieved many benefits by developing Toro. Let me explain typical benefits. First is the lead time for account provisioning. We can now create AWS accounts in as little as 2 hours, and usually in 2 business days. Another is 96% reduction in lead time related to security settings, created security settings, CI/CD configuration, and other features. In the past, all of this had to be done on the project side, which could take up to 2 months. By automating many of these, we are able to reduce this by 96%. I'll now explain AFT. AFT is AWS Control Tower account factory for Terraform, and the service was released by AWS on November 2021. The biggest point is that Terraform can be used to create and customize AWS accounts. Additionally, Terraform distribution is selectable, HCP, Enterprise, and Community. Here are 2 typical advantages of AFT. The first is GitOps. We can now create AWS account with GitOps. It was previously impossible. Moreover, the amount of code requires only about 20 lines, as shown here. The other is multi-account requests. Usually, AWS Control Tower account factory can't perform any operations while an account is being created. Simply wait for completion, then manually create the next account again. With AFT, it is possible to request the creation of multiple accounts at the same time. The internal implementation of AFT includes Amazon SQS, where requests for multiple accounts are queued, and once the previous account is created, the next account creation proceeds automatically. When using AFT, you need just 4 Git repositories, with the top 3 being particularly important. The first is AFT account request, where you define the parameters that are required for account creation, such as account name. And only one HCP Terraform workspace is created. The second is AFT global customizations, where you define the common customization settings for all accounts. And the workspace is created for each account. Sorry, go back. The last is AFT account customization, where you define the individual customization settings for each account, and a workspace is created for each account. In the last page of this overview section, I'll show an example of customization in Toyota Motor Corporation. On the left side, global customizations. We manage settings such as S3 block public access and cloud security posture management related settings. On the right side, account customizations. We manage account-specific settings such as VPC configurations. Next, I'd like to talk about the challenge we've faced on the improvement journey over the past 2 years. The first challenge was users break AFT built resources. As you may know, AFT is designed to create and customize AWS account at scale. But it doesn't automatically protect your resources. Users with subsequent permissions can modify or even destroy them. So what to do? Well, if you're familiar with AWS, you know, yes, we decided to use AWS organization HCP for protection. HCP service control policies are different from IAM policies. While IAM policies apply to individual users or roles, HCPs are enforced at the account or organizational level, ensuring consistent governance across the organization. For example, it is possible to protect, as shown here, deny some actions and exclude only specific roles. Additionally, we can use tags to determine whether the resource was created by AFT. The next challenge was the scope of updates. Customizations are not only applied during account creation. Every time we update the customization, we must apply it to all existing accounts. While this can be done using AFT, however, updating all accounts at once is risky. As a solution, we implemented Amazon Event Bridge Scheduler to simulate a rolling update process. In fact, AFT can update specific scopes, such as individual roles or accounts. When doing updates, you input the payload like this to trigger specific step functions. However, adjusting the settings each time can be time-consuming. That's where Event Bridge comes in. For example, we prepare different payloads for each day of the week. As shown in this table, it's recommended to consider the importance of each target. By doing this, we can simulate rolling updates. The next is about GitOps process for account creation. As mentioned earlier, it only requires around 20 lines of Terraform code. However, the inputs are very simple, so manual creating is a waste of time. Therefore, we decided to automate the process using a custom-built web application. Input words could easily be determined based on the user and project information. We already had this information in our custom-built web application, which was developed on AWS to manage project information and user permissions. As a result, generating the the account request tier file from this application was straightforward. This helped reduce not only workload, but also errors. With these improvements, we have achieved more stable operations. However, as the number of features are deployed, managing deployments with AFT at the all accounts or individual accounts has become more challenging. Because we face the requirements such as excluding only a few accounts or applying to specific OUs. To address these challenges, we implemented some simple solutions. This is an example of excluding a few accounts. First, set exclude account ID in the list. Next, we judge whether the current account matches any of the exclude account ID. Finally, based on that judgment, we toggle the resource creation on or off. Next, this example shows at the OU level using a custom fields parameter. First, set the desired version in keyboard format in the account request tier file. In this case, set the OU name. This value is stored in each account SSM parameter store before the customization process. Therefore, we can use data source to retrieve values during the process of making customizations. Finally, simply define and processing according to OU. This approach enables flexible deployment control. With these improvements, managing customizations and data operations has become more flexible. However, over the long term, managing the workspaces automatically created by AFT in HCP Terraform becomes challenging. AFT automatically creates new workspaces, but it doesn't support updating existing workspace settings. Therefore, the Terraform version set in the workspace is not automatically updated after the initial setup. So we needed a solution to update the Terraform version for workspace created by AFT. So we created GitHub Actions to update Terraform versions across multiple AFT managed workspaces. By specifying the prefix or suffix of the target workspaces, the corresponding Terraform version can be updated to the desired version. This enabled us to perform regular updates, such as quarterly Terraform version upgrades, in accordance with team policies. So far, I've talked about AFT, but also Terraform operations outside of AFT. In these cases, unlike AFT, workspaces are not automatically created. Every time a new workspace was needed, we used to create it manually through the HCP Terraform Web UI. However, managing the Terraform version, workspace variables, and run tasks for a large number of workspaces becomes difficult if done manually. Therefore, we wanted to manage Terraform workspaces the right way. So we decided to manage HCP Terraform with Terraform. As many of you may already know, there is a provider called TFE, which allows us to manage both Terraform Enterprise and HCP Terraform. However, we also need to manage the state of the Terraform code used for workspace management. This means we need a dedicated workspace to manage other workspaces. But managing all workspaces across the organization in a single workspace is too large in scale. As a result, we decided to create a dedicated workspace to manage other workspaces within specific ranges. Additionally, we set up a separate workspace to manage those. The workspace named Takayoshi Backend is the only one manually managed. All others are free managed with Terraform. HCP Terraform is not exclusive to our CCO team. After learning about the CCO team's success in managing AWS with HCP Terraform, many internal developers have requested to use it. So we decided to configure HCP Terraform for internal developers using Terraform as well. I'll focus on the particularly important parts shown here. Let me zoom in on this section. First, we provide our internal developers with an environment that includes 2 default workspaces, one for AWS integration example, and another for workspace management. These are initially set up, and further management is delegated to the developers. Next, we have pre-configured various sets for GitHub integration and managing HCP Terraform. Additionally, through customizations in AFT, we have already completed the OIDC setup for linking AWS accounts with HCP Terraform. This is a secure authentication method known as dynamic provider credentials. As a result, our internal developers can start using HCP Terraform securely without worrying about how to authenticate between HCP Terraform and AWS accounts. Initially, Terraform develops and operated exclusively for internal use within Toyota Motor Corporation. Later, we started receiving requests from some Toyota Group companies to use Toro. So we considered how to provide it in a manageable way. To address this, we decided to use HCP Terraform private registry. With this, modules can be automatically registered as private modules by tagging them in GitHub. Also, GitHub and HCP Terraform don't have to be one-to-one. They can be one-to-many. So we integrated Toyota's GitHub as the source with the HCP Terraform private module for each Toyota Group companies. This allows us to provide modules to the group companies without adding more repositories for Toyota to manage. The group companies can then use these modules to build Toro clones. Conclusion. In this presentation, I've talked about balancing governance and agility. When you hear balance, you might imagine something like this. However, Toyota's approach is different. Rather than simply balancing, we work to raise the standards without compromise. At Toyota, we call this Kaizen. And what I've shared with you today was Toyota's cloud onboarding Kaizen. That concludes my presentation. And I hope today's presentation has provided valuable insights for you. Thank you so much.